Hello, so in this video we're going to talk about energy swaps. Right, so a swap is a contract between two counterparties where they agree to exchange a fixed price for a floating price over a given period of time. Okay, these are very similar to interest rate swaps. So if you have never heard about interest rate swaps or other types of swaps, Hull, it's a good review. So take a quick quick look at that book if this is new to you. All right. We are going to in terms of notation, we're going to call swap buyer to the long side. That means to the side that is paying the fixed leg. This is typically a commodity consumer who wants to stabilize, to fix the price at which it will buy the commodity in the future. Okay, quick example. Let's look at the typical crude oil swap. Okay, so suppose you have a refinery that's going to buy oil in the future. This amount, 100,000 barrels per month, okay, over 1 year, right? Let's say this is the current date and we want to fix the price at which we will buy oil in the future. So one possible way of doing that is to use swaps. So let's say the refinery can trade the swap with a bank, and these are the characteristics of the swap. So the fixed price, the floating price, the one that will change through time, has to be tied to some index, and this example is the WTI spot price. Okay, this will last for the full calendar year. This amount per month, 100,000 barrels, which is what the refinery plans to use, which totals this amount over the year. Okay, so the fixed price payer, we have to decide on which side of the swap we want to enter. So if we are the refinery, we want to be the fixed price payer. Okay, so this would be the refinery. Okay, the bank would take the other side, would be the floating payer. Right. So suppose a scenario. Suppose that in the first month of the swap, so in January next year, the floating price, the WTI, is at 95. So we are going to compute now the swap payment. The refinery owes to the bank the quantity times the fixed price, the 92. The bank owes the reverse, so 100, the quantity times the floating 95, which means that the bank owes more than the refinery owes. So the bank pays to the refinery the net amount, the 95 minus the 92. All right. So this cash inflow of 300,000 to the refinery is exactly the amount that will compensate the refinery for having to buy oil not from the bank but from the usual market, from the usual supplier, at the current price that is on the market right now, 95. So the net effect is that the refinery is effectively buying at 92, which was the fixed price in the swap. So the hedge is working as it should. Okay, and this will keep going on for the full year. So we'll have a different outcome in February, a different outcome in March, different outcome in the last month, which is December. But in all cases, what the refinery gets is that regardless of the floating price, regardless of what we see on the market at that month, it is always an effective cost of 92, which is again the fixed price in the swap. So it works exactly as it should. It fixes the price for each month of the calendar year. Okay. So one important result is that the swap equals a portfolio of forward contracts. So what we are saying here is that having a swap is just the same thing as doing a bunch of different trades with forward contracts. So if we are on the side of the swap buyer, so we are paying the fixed leg, we get exactly the same payoff in each month, like in the previous example, in each month, as if we had a long forward for each one of those months, right? So this is the example. Suppose the refinery had instead entered into a long January forward contract for the same quantity at that same price, okay? So what will happen in January is that the refinery will, since the refinery is long, it will pay the initial price, okay? It will take delivery of the oil. It can sell the oil on the spot market, so the spot price that we are assuming here is exactly the same as we were assuming in the previous example. So it will sell the oil for 95, which is a profit of 3, the 95 minus 2, okay? And it will buy the oil from the usual supplier at the 95 price, $95 that we see now, okay? So considering everything, considering the profit in the forward contract, the effective cost is still the same, 92, as it was before, okay? If the contract had been closed a few hours before expiration, we would have, instead of this physical settlement here, we would have financial settlement, but the final payoff would be exactly the same, $3 per barrel, and therefore the effective result, the effective cost of the oil would be still the same, $92 per barrel. Okay, so the main point here is that a swap can be replicated with a portfolio of forward contracts covering all the settlement periods of the swap, like we just saw. Okay. All right. So now an interesting application here in the energy market is differential swaps. Okay. So what is a differential swap? It's very similar to a standard swap, but now the word differential means that what we are exchanging is a price difference. Okay. So there is a difference between two products, and this will be a fixed amount, and the other leg will pay the spot difference between those two prices, so a floating price difference, if you will. So typical applications here are going to be the following. We are going to use these differential swaps for the following hedges. So we can do a swap on jet fuel minus heating oil, a differential swap on natural gas at a given location minus the natural gas at the reference location, like the delivery point of the futures contract. We can do a difference between refined petroleum products and crude oil price, and this is called a margin or a crack swap, like we discussed before. We can also think of a difference between Brent and WTI oil, and so on, right? Like we used before, we're going to call the swap buyer the one that is paying the fixed leg, right? So differential swaps are also called basis swaps for the following reason. So recall when we talked about futures, we said in energy it was important to decompose the basis in two parts. The first part was the difference between the futures price and the underlying price at the delivery location of the futures. And that was called the storage basis. And then a second part was the difference between the price of the underlying product at the delivery location, and so minus the price of the actual thing that I need, which could be the same commodity in a different location, okay, or it could be even a different commodity, okay. And so these differential swaps are going to be useful to hedge exactly that second part, which is not covered by the futures contract, right? So let's see this example here. So suppose we have an industrial company, let's call it ABC, that uses a given amount of natural gas per month to generate heat for its production process. So a company that does I don't know, paper or cement or something like that. All these industrial companies use a lot of heat, so they require some fuel to generate that heat. Okay, so suppose the plant is located in Chicago, and it pays the spot price there where it needs the natural gas. Okay, let's say it's April, and the manager wants to hedge the purchase price for next year. Okay, so the idea is that he's going to do the hedge in two steps with two trades. So first, he's going to buy Henry Hub natural gas futures, okay? And he's going to need two contracts for each month, because recall each contract was for 10,000 MMBTUs. We need 20, so we need two contracts per month. And let's say that these are the prices. So we have a price for January, we have a price for February, and so on, until the price for December next year, right? And why do we want to do this? Because, well, this futures contract is a liquid contract, so we are going to adjust easily if we need to in the future, right? But then we do not want to hedge the price of Henry Hub natural gas futures because we are located in Chicago. So we need to do this second step, which is going to hedge that difference between the physical location of the location of the delivery point of the futures contract and the location where we really are. So the difference between Henry Hub and Chicago, right? So that's what we're going to trade with someone else, let's say Bank XYZ. So we're going to look at, we're going to ask for a differential swap between where we are, Chicago Hub, and the delivery location of the futures contract, the Henry Hub location, right? Let's say that the bank quotes this differential swap. So if the fixed price is 0.4 for the year that we need, for the quantity that we need, and so on, okay? So who is going to be the fixed price payer? Well, we, the ABC company, are going to want to be the fixed payer. So we are going to pay this fixed part of the swap, all right? And the floating payer is thus the bank XYZ, right? So let's see whether this works. So if this works, what I hope to get is the following. I hope to get the fixed price for January that is going to be the futures price 465 plus the swap 0.4. So the industrial company ABC is guaranteed to pay a price for January of 465 plus 0.4, so $505 per million BTU of gas in January. A different price for February, a different price for March, and so on. For December, the price I'm going to pay, no matter what, is going to be 4.6 plus 0.4, so $5 per million BTU, okay? Regardless of what happens to the market over the following year, okay? So let's see if this works. So let's think of a scenario. Let's say for the first month, for January, let's say that these are the spot prices, okay? Henry Hub 4.8 and Chicago Hub 5.3, okay? So I look at these prices, and when I'm here, I think, okay, it's good that I have hedged, because if I had not hedged, I would be paying 5.3, and if everything works well, I will be paying just 465 plus 0.4, 505, which is less than 5.3. Okay, so let's just double check that indeed what I'm paying effectively is just 5.05. Right? So let's go through all the details. So the first trade we had was the futures. So let's close the future. Okay, I was long the futures, so compute the payoff for the long position, given that this is the price at which I entered into the long futures. This is the final price, okay? So I get a payoff, which is positive in this case, and make sure that you get this number, right? So that's one. So now let's go to the swap. The swap, let's see, how much do I owe? I was the fixed payer, so I'm going to owe the 0.4 times the quantity, okay, some amount of money. And the bank is going to owe me what? It's going to owe me the same quantity times what? Times the differential right now. Well, how much is the differential right now? Is the difference between the current Chicago Hub price minus the current Henry Hub price, right? Because you call the differential swap is Chicago Hub minus Henry Hub. Okay, so I do this difference today, and that's how much the bank has to pay. I see which one is bigger, and someone is going to make a profit, the other side is going to lose money. So in this case, ABC has a cash flow positive 2,000. So ABC receives money from the bank. Okay. So what else? Now ABC actually has to buy the natural gas at the location where we are, Chicago Hub. So we're going to pay the quantity times the actual price today of 5.3, right? This is the total we need to pay to buy the gas, okay? So the net amount of all this stuff is what? I have to pay this, I receive this from the swap, I receive this from the futures. So net, I'm just paying 101, okay? And if I divide this by the total quantity of gas that I'm buying, the 20,000 million BTUs, this will give me a net price, an effective price of 5.05 per million BTU, which is exactly what we were expecting, right? The 4.65 plus 0.4. right? So the hedge worked. Okay, this would keep going on for the rest of the year, and this would be the last month, December. This is some other scenario. Just make sure that you are able to do all these calculations, and again, make sure that the effective price that you're going to get is what you expected. What did you expect? You expected 4.6 plus 0.4. You expected 5, right? And that's exactly what you get. You get an exactly a price of 5. Okay, and obviously this works for whatever spot prices happen in the future. So you can do this example again with different prices here at the end, and it will always be the case that the effective price is 5. All right? Okay. Second result, which is important, the first proposition that we saw was that swap was a portfolio of forward contracts, and here the result is very similar. A differential swap is still a portfolio of forward contracts, or more precisely, a portfolio of forward spread trades, right? We talked about spread trades when we talked about forward contracts, and it's that type of trade that we are thinking. When we're trading a spread, we are trading two different contracts. We are going long in one and short in the other, okay? So the result is the following. If I am a differential swap buyer, like this previous example, firm ABC, if we are buying the swap, then the cash flows we have are the same as if we are the spread buyer, meaning recall what we did when we talked about spread trading in futures. A spread buyer, we mean that we are buying the high price and selling the low price futures, right? So we are betting on the spread to increase, right? So this is the proof that you can see that the payoffs are the same whether I am a differential swap buyer or whether I am a spread trade buyer betting on the spread increasing. Okay, I get the same payoffs in the first case and the same payoffs in the second case, right? So what this is saying is that I can replicate a differential swap with trades in future contracts, right? So for the previous example, suppose that we had Chicago Hub forward contracts, and these were the prices that we have for the following year. So for each month of the following year, okay? So for each month, instead of entering into the differential swap, I could instead do these two trades here. I could buy the high price, the Chicago Hub price, and I could sell the low price, the Henry Hub price. All right, and so what I would get here is, so for example, for the last month, for December, I would get these payoffs that you see here from the Chicago Hub forward that I was buying, the Henry Hub futures that I was selling. I would get these payoffs. The total from the spread trade would be this result here, and the net would give me exactly the same result as the differential swap that we had before. Okay, again, so this is just to show that if I have forward or future contracts available, I can replicate a differential swap. Okay. All right, so finally, just some additional examples of hedging, typical examples in the energy industry. So a very common example is this jet fuel heating oil hedging through a differential swap, right? So the typical example is this. We have an airline company that needs jet fuel, some amount. It's based somewhere, let's say in Dallas, and it pays the Gulf Coast price. And this example is based on a company called Southwestern, which is a small company in the US. So it's the same type of idea. We are at a given point and we want to hedge the purchase price for a given period in the future. Okay. The problem is that there are no jet fuel futures, right? So what airlines typically do is to do hedging with something that is close, which is heating oil futures, right? So we could We could try to do a simple cross hedge by doing the type of things we discussed when we talked about futures. So we'd have to estimate the covariance between the spot and the futures price and do that adjustment to the trading and just do that cross hedging. However, that would not be optimal in the sense that we would still have some risk. Okay, what type of risk? Think for a second about this. We can discuss this in class, right? So what we can do is to make the hedge tighter. We can do the following. We can hedge with the heating oil futures, which is what exists, what is available, and then a second trade, which is a differential swap, to convert from what the future is actually hedging, which is heating oil in the New York Harbor, which is the delivery location of that liquid futures contract on heating oil, and what we really need, which is jet fuel in the Gulf Coast. Okay? So again, the idea is that we will hedge in two steps. First, we'll buy this very liquid CME heating oil futures, right, for the set of months that we need to hedge. Let's say it's this full calendar year, okay? And then we'll add to this a second step, which is the differential swap between that price, okay, the New York Harbor heating oil price, and what we need, which is the Gulf Coast jet fuel. Okay? So we go to a bank, let's say the bank quotes this price, 0.05 per gallon, and we adjust the period and the quantities to what we need, right? Again, we are the airline, we want to fix the input price, so we want to be the fixed price payer on this differential swap. Right? So again, let's just make sure that this works. So for example, what is the price that I'm hoping to fix for each month? So for example, for January, this is 2.9 for heating oil, plus 0.5 to convert from heating oil in New York to jet fuel in the Gulf Coast. So the total price that I'm expecting to pay is 2.95, right? So let's see if this works, right? So given scenario, let's say that these are the market spot prices when you get to January. Compute the payoff from the first part, from the futures. Compute the payoff from the second part, the swap. Should be getting this. And this is how much you actually need to pay to buy the jet fuel in the spot market at this price here. And once you consider everything, the net or the effective price in the end, it's going to be 2.95, exactly as we were expecting, 2.90 plus 0.05, right? So it works exactly as it should be, right? So this is just a small comment about regulation and how the market evolves. Basically what this is saying is that there is some regulatory requirements that may make firms move more from swap to futures trading, but what we have just discussed with these propositions is that both things are equivalent. So I can always replicate the effect of differential swap with a portfolio of forward contracts. So even though this regulation changes may move the way or move trading from one venue to another venue, in economic terms, things do not change that much because I can always get the same economic outcome either with swaps or with future contracts. All right, that's it.